Hello, everyone. I hope you guys can hear me well. Let me share my screen quickly and we will get started with the webinar again. So here we go. I hope everyone can hear and see me well. So today we are covering the topic in our 7th session of Chapter 4 with GoUp. And the topic today is data collection and processing for AI. And our guest speaker today is Avi Gopal, no one else than Metabob's CTO. And to describe Avi as a person in a very concise way, I heard this description a couple of days ago from Avi's roommate and another colleague from Metabob who called Avi the walking Wikipedia because he is rarely wrong about cryptocurrency or tech overall and AI. So I'll leave a more in-depth introduction of Avi for himself, where he can give you a more wholesome picture of what he does and who he is. So here's our agenda for today quickly. So we'll start with a short kickoff, then we'll quickly move to Avi's presentation. After the presentation, we'll take a little bit of a water break because as I mentioned, it is right now boiling hot here where I am in Portland, Oregon. So I know that I will need some water to add into my system at least. And from there, we'll move into our Q&A session where you'll have a chance to connect with Avi and ask individual questions from him for some time. And after that, we'll wrap up this session and that is it. So as I mentioned, this is the 7th session of our Chapter 4, and it is hosted by me, Axel. I do work in growth marketing for our partnership company, Metabob, who we are hosting this webinar in collaboration with. About myself, outside of work, I am really passionate about sports, especially soccer and basketball. And as I said here, I'm also very passionate about technologies enhancing employee efficiency. Quickly about our partnership company, Metabob, which is the fast, easy, and visual way of debugging code. So it is an AI-assisted tool that cuts developers' debugging time from Python code by half. So if you're doing Python projects, make sure to check Metabob out and use it for your projects. So here we have our Chapter 4 Contribution Award. And the Contribution Award goes to everyone who can join 8 out of our 10 sessions this chapter, and you'll get a special prize for your contribution for the community. So let's quickly begin here. So as always, we have our Jamboard for the session. So let's spend a couple minutes here. I will drop the link to the chat real quick. I'll stop my share for a second. And here we go. So we have our normal question on our Jamboard, which is, what do you wish to learn from this webinar? And please make a sticky note on the left-hand side here by clicking this and write down, choose your color and write, what do you wish to learn from this webinar? Why did you join this webinar overall? So for example, I want to learn more about the importance of collecting data for AI, for example. So please join, please feel free to add sticky notes here and move them around. I'll make sure that, everyone can edit this. So let's spend about a minute or two here collecting our answers. We were a bit shy yesterday with the board, so let's try to be a little bit more active with it today.
Apologies from me. I'm going to have to reboot. My laptop froze up.
Yep.
So I'll rejoin in a moment. Just a minute.
So there's as a beginner, how can I learn AI? Akhil asked that. And I'm going to stop my screen share for a second. Okay. No one's in the waiting room. Great. And there we go. I want to learn how our data and AI, which I believe are mostly algorithms, are related. So Fiza said that I want to learn how can we collect effective data for AI. And let's spend a little bit more time here, maybe like 20 seconds. This gives us a good overview. Here we go. Perfect. So I am Chandan Kumar, a student, how to get started with AI. So I believe that Avi will touch most of these topics on this webinar, and good. So let's move on with the presentation again. Next, we'll have a poll, and I will launch the poll right now. So the question for the poll will be how experienced you are with AI development. And let me launch the poll right now, and please choose your answer here. Let's spend approximately minute or minute and a half collecting some information from you guys to see and help Avi to kind of know how experienced you are with AI this far. Alrighty, so we have 7 answers this far. So let's spend a little bit more time to get a couple more questions, answers. Experienced, great. Alrighty, and I will now end the poll and share the results. So I hope everyone can see the results on their screen. Can you guys see the results on your screen? Yes? Great. So most of the people are not very experienced with AI, but we do have someone who has much more experience with us today as well. So kind of a diverse population, but mostly inexperienced people with AI. Great. So next one, just a quick overview where people joined us today. So mostly we have many different Indian cities from Vietnam also joining. Then we have someone from California, New York, and of course, Baku is always represented in GoUp's webinars. But India is a dominant location today where people wanted to join us. I know it's late for you guys, so thank you for joining us this time, and you're the best making the effort to come here. So next, we'll go over our code of conduct, which is really straightforward here at GoUp. So we're here all to learn, benefit, and contribute from these webinars. There is no marketing, selling, or competing allowed in the webinars. And also, it doesn't matter what your role or background is. We are all equal in this space, and we're here to learn and have fun together. With this being said, I'll stop my screen sharing for a second, and we'll take the classic photo of this webinar, which will be posted to our social media as every time. And after that, I will finally pass the mic to Avi Gopal, who is our guest speaker today. I know you guys are much more excited to hear his words than my words. So let's move into him right after. And let me, please open up your cameras, people, and let's take a quick photo. And does anyone have an idea of which kind of sign we want to do? Peace sign is a good one. So 1, 2, and 3. There we go. Perfect. And Avi, with this being said, the floor is completely yours. You should be able to share your screen again.
Nice. So should I probably start by going over some of the questions on the Jamboard, just so that I can like give a bit
sure.
more
You
of a
can
response?
you can definitely do that.
All right. So I'll just start by doing this then. So basically, the goal for this presentation is not necessarily to talk about how to get started with AI itself, but more so once you have like a good understanding, or once you want to start making your own AI product with your own data and your own outputs, you're going to need to like go through that process and collect that data and then be able to use it for your application. So if you are starting out on AI just in general and want to learn the techniques and the processes in order to like develop an AI solution, I would recommend probably just going over to a place like Kaggle and just collecting a data set that's available there. Everything that we're going to be talking about today has already been done for you. So then all you need to do is focus on just learning how to deploy the techniques to get meaningful outputs. But if you want to figure out how Kaggle like makes those data sets that you can use, that's the primary topic of today's like discussion. So without further ado, let's just get started. I hope the screen sharing properly. Looks like it. So some quick background about me. I have like an engineering research like history. So previously I was working on more like physical projects. It was optimizing different sorts of airflow designs and the like for varying like aerospace applications, but primarily to help improve efficiency of wind turbines. And then afterwards, like many of the same techniques that you would use to do the optimizations for these are based in numerical analysis and like numerical processes to do refining of different parameters across different conditions. So that lends itself very nicely into what you would need to be doing in order to learn for an AI itself. So I had like a good functional background when it comes to transferring my skills over to AI, which I did almost immediately as I started doing lots of autonomous vehicles and like area mapping type projects. And all of this was computer vision. So I was identifying different sorts of objects within a real-time environment, and then also going through and determining both what they are and whether or not you should be avoiding them, as well as going through and like making sure and keeping track of different sorts of markers that are available. So there's varying techniques to do this, but as I sort of went forward, I used more and more sophisticated techniques in order to find more and more sophisticated types of patterns. And that's basically what you would want to be doing if you were starting it yourself. Start with some simple use cases with some simple processes. And even if you're working on like an enterprise or production level project, it's always good to grow into your AI requirements as opposed to trying to do something that's overly complicated right at the outset and then realizing that you've wasted a lot of time because you either didn't have things set up properly, the technique you're using doesn't correspond well to the use case that you want to have it set up for, or that you are trying to, or that you just don't have the right kind of data in order to make inferences using the type of hypothesis that you had envisioned earlier. So while working on the Metabot project, that's basically what we were responsible for doing. And in fact, when I was brought on to the Metabot project, we had like another group of researchers who were primarily focused on doing the AI development. So my job initially was doing the data processing and data engineering to get everything in. So let's just go into what am I talking about here. So when it comes to data collection and data processing, they can be collectively combined into something called data engineering, which is this entire process of going out there into the real world or into like the virtual world, finding out what you need in order to perform some inferences and bringing it over to you and just storing it or keeping it and transforming it into a regularized way so that everything is easy to digest for the data science team or for people who are further down the road who are going to be consuming this data and using it for their own analyses. In fact, you could very easily form an entire company just around doing this like first step, where all you do is go out and find certain analytics, track them, provide like a nice platform for saving or storing or forwarding them to different places that are configurable, and then just going through and like organizing the inflows from varying disparate sources of data. So they can be from anywhere, depending on your application. They could be either live or non-live or local or non-local. They could be things from like Twitter or like Facebook, so like social media data, essentially for people who are working in different groups. So if you're doing like business analytics or marketing analytics, and you want to track how certain memes that you're producing are spreading throughout the community, that's a source of data that you have identified. And in order to learn how that is happening, you need to go out into the world and collect that data, and then be able to put it in such a format that you can do the appropriate sorts of analytics to it, so that you can learn some underlying pattern. So the first thing that you would need to do before getting even started with any of this is understand like what the problem statement that you're trying to solve is. And that is heavily dependent on what you are interested in doing. So basically all of this stems from trying to solve some problem. And unless you have like that well defined before moving into it, you could very easily end up lost in what you need to collect or how things need to happen. So the easiest way to get started with that is basically to go through and just consider what you'll be doing in terms of the use case of the data. So let's say, for example, like with Metabop, what we were doing is we wanted to help developers create some insights about what types of issues that they are encountering. So we need to identify basically all of the potential sources that could be from or related to that use case, and then decide how we wanted to put it into a framework. And there's really two phases of this. There's like an exploratory phase where you're not necessarily sure about what data you need and how relevant it is. And there's also like, I guess you could say, an evaluation phase where you're going through and you already know that that what you have is functional for your use case, and that you have like something that's usable. You just now need to keep it up to date and then scale it to approach like what the actual ingestion rate would need to be, or what the production rate is more explicitly. So if you're streaming everything from Twitter, you can start with a couple of tweets, and then once you have those, try and determine if there's a pattern between them. But then afterwards, you're going to need to like automate this entire process. And that's more of what we're going to be talking about today, how to automate and build out this process in a way that is both scalable and will help you solve your issues, and be able to like easily extend to new types of problems as you want to solve them. So basically, the functional viewpoint of all of these things stems from like this general flow. So you've got your data ingestion, where you've got like different sorts of data sources. So you have your bounded data sources, which are like single events that are just things that exist in the world. So these are files that contain different sorts of things. So like in our case, our input data was primarily pull requests from GitHub and Bitbucket, as well as GitLab. So for those, what they are just like bounded data sources. So they exist in a one-time event, and once you collect them, you can usually collect them again, because they still exist in their source location. And then you also have like unbounded data sources. So these are things like the Twitter stream. So as people make new tweets, you want to keep up with that, or as like an IoT device that you're reading off of in order to do some analytics on it, it's producing more data, it's continuing to produce it. And these are things that are very difficult more often than not to try and figure out what it is ahead of time. But what you're doing in there is you're feeding in both of these, and then you need to do the processing step for it. And that's basically what happens afterwards. So usually with bounded data sources, some of them are even like database tables that you may be collecting for your company or for your customers. And if you just can read these indirectly and see, oh yeah, here's your sales history for like the last quarter, we can do some analytics on it to determine where you are underperforming and how to assess that. And that's your business goal. Then what you would want to do in the next step is to, well, in order to determine where they're underperforming their sales, maybe we should figure out what their sales like strategy was, and like what what their data is on the input side, what their lead generation is like, how they were processing these leads, and also how they were converting them, and what were they converting them to, and what were they unable to convert to. So all of this is usually stored within a database on their side. So if you have access to that database, you can then just start performing the analysis on this data and developing your model with that. But in some cases, this is something that's not very readily tracked. And if they have like a very large sales team and it's not like explicitly put into a way that's easy for you to process, then how are you supposed to track that? And that's another sort of problem that you'd be encountering typically. So what you want to do there essentially is to buffer and store that data as well as to regularize it. So what exactly are what are like the best practices when it comes to doing data ingestion on the side? And firstly, as mentioned, it's to be very clear about what you want to have as part of your collection strategy, and have a clear goal about how you're going to be building your models, or not necessarily what you're going to be building their models out of, but more so what you are trying to prove, or what the insight that you're trying to generate is. As well as once you have that, everything else follows fairly nicely. So then you need to identify like potential data sources for your source. So in this case, let's say we're doing that sales example again. As you are talking to this customer or to varying customers to help them define their sales strategy or their sales pipeline out a bit better, you'll need to know what data do they have that you can use. It could be different files and different people's machines from different like individuals who are keeping track of their own like their own books. They may have like a CRM software to do outreach. They may have different sorts of like streaming or events that they trigger typically, like every time they need to schedule a new meeting or schedule a new call with different customers. So there could be calendar invites for this, or like Zoom links. And all of this is something that's very like important to track, because if you are going to go through and try and identify like what's everything that somebody needs to do in order to like perform a sale, you can then kind of define, well, all of these things need to be done. They need to talk to a customer. Well, they need to first identify potential customers, and they need to find out which ones are interested or working on projects that may use a product that's being provided. Who then you need to reach out to, or identify who to reach out to from those teams or from those companies in order to like do the sales. And then you need to then do the actual sales process and get them on the phone or arrange a meeting with them and then like actually go through. And all of these things are data points that you need to keep track of. And for the most part, they may keep track of them, they may not keep track of them, and they may keep track of them, but not all in the same table. So what data ingestion is taking all of these disparate data sources and putting them all in one table, along with the additional like information surrounding them and their context. So the next step here, I mean, like the next thing to do here is also to like make sure that you can integrate very well with all these sources. So as mentioned earlier, basically, we had 3 or so data sources that we had like identified. Some of them are from places like Google Calendar, where they may be doing the invites or setup. So you should integrate with that so you can collect like your sales teams like scheduling and how often are they making calls to these customers, how long are these calls typically lasting, as well as who are they talking to, how are they finding them, and how often are they converting. So all of this stuff needs to be collected. They all look different, but it's just important right now to keep them all in one place. So you also need to keep track of like when these data points were generated, as well as like who they're for, when they were used, whether or not they were rescheduled. This kind of stuff is very important as well, because it helps inform like the overall context and can help you color the data later as you are doing the actual analysis, so that you can better understand some of the more like nuances when it comes to the collection. So while you're doing that process, make sure that you don't worry too much, especially in the explicitly in the exploratory phase, when you don't have like a clear understanding of the problem, or not the problem itself, but a clear understanding of the solution that you're going to be creating, or the solution that you are generating currently, and you haven't like built out a model yet, or you haven't like formalized your processes yet. It's very important just to collect as much data as possible, not filter it ahead of time. So don't like only look for sales to certain types of companies, or only among like one product line, or anything like that. Simply because like if you do that, you're gonna lose out on getting like a good baseline metric. So even if you are like trying to help them with like one specific type of product, like maybe they sell like cell cultures or something, for some bioprocesses, and they also sell like food services to other people using like a slightly worse version of whatever they have available. And if they do both of these things, like they sell to pharma industry and they sell to like food manufacturers, uh, you shouldn't only collect the pharma industry sales information, because you need to understand like how does it compare to the broader set, so you can help identify anomalies. And if you filter things ahead of time, you won't have that data to look at, and therefore you won't be able to do analysis on it. You won't be able to like predictively analyze whether or not something needs to be adjusted, or like be able to learn any insights from the differences between those two. And also, especially, do not delete anything. If you're collecting data, it's good to have it, and as long as you have it, then you have it. If you delete it, you may not be able to get it back again, especially if it's something that's unbounded and just therefore unstructured. It could be something that just comes in every now and then, like a report from some logging tool, or a report from some like analytics collector that they already have running, and this stuff may be difficult to obtain later. So it's very important to just keep everything together and keep everything packaged, because you can always add or subtract later, but you can't add easily, and that's usually the thing that takes the longest in most AI projects, especially for our project, which is like collecting the data in the first place. So to go over a little bit about what my experience with this whole process was, as mentioned, we spent like the first couple months working on this project in the exploratory phase, and I was not like the principal researcher at that time, so I was mostly involved in getting the infrastructure set up to do the data processing. And for that, what we had to do is identify, well, here is the things that we are going to be calling upon in order to help us learn what the best programming practices are. So our goal was to find and identify certain areas of the code that would need to be updated or changed. And we need to figure out how would somebody learn, or how would somebody know what code needs to be changed. And most of that stuff stems from like an individual developer's experience and their history, like making different sorts of code changes to a different sort of platform. So from that, we identified these like 5 main categories of data. So we needed open source repositories. Well, we didn't need open source repositories explicitly. We just needed repositories. It's just easier to get open source repositories. But we needed repositories that had like a good tracking of the code history itself, along with a documentation about why different code changes were made. In open source repositories, this is a standard practice, simply because there are multiple people working on it at the same time. They're not always in the best communication with each other. So they do need to have a lot of things written down in their documentation in order to allow people to easily get started with their projects. So we identified that as like a good source of input data, and more specifically, the pull request for the most important bit there. What we didn't initially track necessarily was all of the issues that they created, but then we later learned that that was something that was very important to include. So we kind of made a mistake there, and the solution is to also get the additional information. So if you have the option to get more data, always get more data. Like there's never really a downside If you learn later that you don't need the data, just stop collecting it at that point. But like, if you don't know what you don't need yet, you need everything. So just get everything. So we also need like company SOPs. Luckily, we were working with NEC at the time, so we would have like access to their general standards for that. Some of that's also available in these open source repositories. They do have like a typical standard of doing things that are included within the linter configs they have set up. So to a certain extent, we can identify from their current usages, both what their like design standards and their SOPs are in terms of both architecturally and systemically how things are working out. For program analysis, this is something that we would need to generate for each repository itself. So once we have the code base itself, we would need to go through and like generate different sorts of data based off of like a supplemental or enrich the existing data in a way to get more information from it. So from the source code, you can get additional metrics about how complex something would be or how many cycles something would take by just doing generalized operations. And then we'd also want to collect like the manual code reviews for these repositories. And this was more specifically the pull request data. So basically, it would be both the review itself and then also the discussion about the review. So everything that somebody would be doing in order to like make a change and also what they were doing historically to make that change. We also need to collect that. So all of these things were what we primarily identified as what we would be most interested in collecting. And we had that goal in mind at the beginning before we even decided upon what data sources we would want to identify. So then after we have all this set up and we build out the ingestion pipeline to collect them, and we built like a set of scraper like bots to go to places like GitHub, find these open source repositories, and then like mine them specifically for these pull requests, and then also later the issues, even though we kind of neglected that first pass, as well as like the other information that we'd be mining from the code base itself, which are more architectural information about how code is structured, as well as how the code performs. So all of these things were like extracted directly from either the raw source code or from the documentation surrounding the source code. So then we moved into the main data processing step. So the biggest step I can give you guys here is that if you're working on a project and you're going to be doing data processing, don't try and make it too robust too soon, because again, especially in the exploratory phase, you aren't necessarily sure what needs to be done to this data in order to achieve your goal. So in our own, like in Metabot experience, we did do an extra data processing step earlier, which was the program analysis. So we analyzed like the complexity of different sorts of features. And like we were doing this in a very sophisticated method, actually, that was developed by one of our researchers. But it was not helpful in the end. So it wasn't something that really helped us out to much of an extent, and you just kind of like slowed down the entire process. And this is because we kind of jumped the gun a little bit, and we did more processing than what we needed to do. So you should really follow the data whenever you're doing these sorts of operations. You should go through, and once you have the raw data, start doing the analysis. Or actually, well, first what you should do is start regularizing the input. So to make sure that everything like looks the same or can fit nicely in a single table, so that when you then perform the analysis on this data, it's very easy to draw from. And by analysis, I mean this is just basic statistical analysis for the most part, at least at the beginning. And you get more and more sophisticated as you exhaust the simpler methods to identify the pattern. So depending on what your data looks like and what your use case is, sometimes like just the statistical methods work very well. Like all you would need to say is if I have these certain things in this high quantity, then it's a potential like danger sign for this sale, or it's a potential issue for this product, or there's going to be an obstacle hitting the front of my vehicle if the 3 sensors in the front of it are registering less than like 1 meter to an obstacle. So all of these things, like for certain operations, it's very easy to generate like a very simple statistical model. And if you try and go too complex too fast, you'll make something that's not optimized for the problem itself. So start with just the raw data. Do the basic operations for it. When these basic operations fall short, use the learnings from those basic operations to reduce the number of features that you're getting in on the input side. And then do slightly more complex operations and that reduce the features. And keep doing that until you either achieve your goal or you realize that you don't have enough data at the bottom, panic a little bit, go back to the data collection, see if there's anything else that you can gather or learn from the existing data, create those features, and then repeat the process. So that's generally the workflow that you would want to pursue. And in order to help make this the most efficient as possible, you should also save like the intermediary steps. So as you are doing these reduction operations on the data, just like make sure that you are storing both states. So both the raw data and then like after the first pass of the processing and then after the second pass of the processing, third pass of the processing, because you could be able to fork from one of those previous steps into a different like type of analysis or a different type of processing to get more information out of it. And if you had deleted that intermediary step as you were like advancing your process, and you don't save it anywhere, and you like just have already completed that step, so you say, oh yeah, well, we're done with that. We don't need to do any more of that statistical stuff anymore. We just need these like 3 features that we think are very highly correlated with the data. So we're just going to use those. And then later you realize we can't just use those. There's actually more information that we need. But now you have to go back through to the raw data and then redo all the processing again. It's just more efficient to keep the step where you have all of the statistical things that you processed already, and then just keep them. And then later, if you realize you do need them, you'll have them, and you can easily like stem from those ports there. And then as you are developing this process, then you can move on to doing like more enrichment of the data. So in this case, this would be things like using like more sophisticated techniques to find different patterns. So as I mentioned earlier in Metabob, we had that program analysis that we were doing. That would be one way of enriching the data to get some more information from it. So we can learn different items from the source code that isn't like explicitly tracked in the source code, but is determinable from the source code. So if the raw data itself is not sufficient, then you should move on to generating these enriched data points and not try and like enrich the data too soon. Otherwise, you will encounter like a different sort of issue. So let's just quickly go over like what the general like lay of the land looks like in terms of tooling for these things. There's a lot of symbols on here. So I'm just gonna tell you basically to ignore most of them. And what's really important here is that when you have the ingestion source and the output source, what's important here is how you're piping in the data, right? And for most of that, that is through like general services like Apache Spark or Hadoop, which are generally pretty well regarded in the space. Spark's used quite a lot in terms of like generating or setting up like whole ETL or data ingestion, data processing pipelines. And the reason why people do that is because it also scales well, but for the most part, it does have like a nice Python interface, so you can also very easily set up the data analysis as individual steps. And it's very easy to hook up to the existing like message passing infrastructure that most organizations have already. And it works very nicely with the existing tool set on like AWS or GCP, where you have the option to like feed in things into their big data tables or S3 or Kinesis like data stores, and feed those in directly into these services, do the processing, and then feed those out directly into like the long-term storage or into Databricks or something where you'll then be doing the further processing on each application. And every time that you are making certain changes, you should also store these intermediary steps, probably in something like S3, just for archival reasons for the most part, and then move forward. So if you are starting out with the data engineering side, maybe using something that was well regarded is better. But also, as I mentioned earlier, don't necessarily worry about scaling too much. It's more important that you get the data in at all before you start trying to determine what you will need to do in order to actually scale the operation. Because depending on your use case, all of this might be too much, more than you would even require. For some usages or some types of models, just having some like single S3 like table with some data on it, or not S3 table, but a single like database or HDFS like table on S3 that you can just pull from or have your data scientists pull from in order to get some ground truths, and then build the model from there. That might be all that's required to build your model. And then once you have that model, you can just use that model. But for other use cases, you need to constantly adapt the model to changing conditions, and that's more where this comes in. So the goal obviously is always to learn what model you will need to have in order to best fit your use case. So if you have something that can be just like one and done and then just needs updates periodically, then you should just build for that solution and not worry about trying to build like a very sophisticated data ingestion pipeline if it's not required. So, I mean, the ingestion you'll always need to some extent. It's always good to automate that. But the processing and stuff, that if that doesn't require like all of this stuff to be happen automatically, then don't have it necessarily happen automatically. I mean, don't like build out an entire infrastructure around it if it's not going to immediately help you. So always keep that in mind whenever you're making decisions when it comes to how you're building things out. So I also want to talk a little bit about how we're doing the actual enrichment of data now. So as I'm sure many of you may have heard, Ben was here earlier doing another webinar. Unfortunately, I wasn't able to attend, but I'm sure many of you were able to attend. And for Ben's like webinar, he was basically focused on like helping you or like explaining how to do topic modeling to get certain information from like text data using NLP. And that is one of the types of data enrichment things that we're doing as well. So what we had learned was the data enrichment we were doing before to get like the program complexity wasn't very helpful to us, but the data enrichment we're doing here to classify different sorts of bugs into different sorts of categories was very helpful to us. So now we have it part of our like data ingestion pipeline. So as we scan for new repositories and new repository changes, as well as people are using a platform and making changes to their own repositories, what we do is we use our topic modeling system to like learn from the surrounding context of these pull requests that they're making to classify them into different groupings automatically. So that's basically an enriched portion of it. So we're using this now more sophisticated method in order to add more context to existing data that didn't exist prior to us doing that. And this is sort of emblematic of the whole process, right? So we had the data, we tried to do the analysis, or we tried to achieve our business goal with the data that we had. We realized that we were missing some data, which was we didn't have the issues database. So we didn't have enough information necessary to come to a good conclusion about why these code changes were happening. B, we didn't know necessarily what things we needed to do in order to reach that goal by just going through and looking at the code itself, which is why C, we realized that the program complexity wasn't beneficial to achieving our end goal, simply because like from that information alone, there wasn't enough context, or there wasn't enough of a discriminating factor to classify something as either a problem or not a problem, using only that or using that condition as along with the additional data. So because we already had all the existing data for the pull requests, and then we later realized to collect the data for the issues, we could then learn that basically we would need to also go through and probably figure out some way to identify which categories of bugs certain things were. And the way we decided to do that was to use this topic modeling approach, because we already had the textual data surrounding each code change. And what's the next logical step is, because we already have that in our database, why not use it to try and generate some meaningful insights, and seeing if we can enrich the data to better meet what we would need to have in order to achieve our business goals. So after we added in the topic modeling data, then we were now enabled to do other more sophisticated approaches to identify different sorts of bugs. And what turned out to be the case was this was exactly what we needed in order to make these sorts of inferences about where bugs were located. And that is the process. So that's the main takeaway that I wanted to share with you guys today. I know we're basically close to the end time, so we did want to break for questions before this, or did we want to do something else?
We can take a short break actually for a couple of minutes, grab some water, think about questions. We have some questions on GitHub, so we can next go over them. But let's take, say, 3-minute break. For example, then we'll start with live questions. I see Akhil's hand is up, for example, and take those live questions and then move to the GitHub questions shortly after. So let's all take a moment of break, and let's be back in 3 minutes. So PST 10:56.
Okay. Let's go back here to shot.
We can't hear you, Axel.
Alrighty.
I can't.
Yeah.
Now, yes.
Yeah. I had my microphone on mute. But yeah, slowly getting back. And Akhil, are you already back? You can ask your question
Yes.
to Avi whenever you're ready. So go ahead.
Yeah, I'm ready. Can I shoot a crypto question?
Crypto question.
Yep.
Yeah.
So, yeah. So when I saw this cryptocurrency thing, when it's booming, I thought it's too volatile. And there's also another person who thinks the same. He's Warren Buffett. He calls cryptocurrencies a delusion or artificial gold, and it's just useless. So what's your take on that?
Yeah, well, it's something that, like, I'm gonna lead out here and say, firstly, this is recorded and also not the main topic of this thing, so I'm not gonna go too far into it. I do have a podcast where I just talk about this exclusively, so I'm sure Alex can link that. He has the link for it. But mainly, the only thing I really have to say to that right now is that it's just simply like a different means to remove certain additional financial operators from the economic system because it's not necessarily required. And for certain solutions, they accomplish this goal much better than other ones that are more popular that have become more speculative. So while I agree that the volatility isn't good, the volatility only exists because we still haven't reached the point where they are well adapted for their use case. And there's different approaches that are more better, closer to this goal than others. So obviously, there are like considerations to be made. It is potentially a very risky proposition, but not for necessarily the volatility reasons exclusively. More so, it's about the long-term usability as like a medium of exchange for like just normal, regular transactions, which has been something that it has already struggled with despite being the primary reason it exists. So we should probably focus more on the AI questions though. So if anybody has any of those.
That's that's true. And Akhil, Avi mentioned the podcast, and I'm happy to send you the link for that podcast next week because you can like Avi can talk about this thing for quite a long time. So
I have talked about this thing for a very long time.
Yeah, so
yeah.
I'll provide you the link to that podcast. Just remind me next week, and I'll send it to you via Slack. But talking about AI related questions, if someone has an AI related question and want to ask him live, please just raise your hand, and I will let you ask the question from Avi. But I'll share my screen quickly because there are some questions in GitHub which are AI related. So first, Rasim asked that what is your suggestion how to collect the medical info for AI processing?
Well, that is a very complicated question, actually. It depends on where you're located. I'm not too sure what the exact situation is in India currently, but at least in the US, we have something called HIPAA or HIPAA, or yeah, I think there's 2 A's and 1 P. Don't correct me if I'm wrong. But basically, it's a set of regulations that are about data privacy with respect to health information. So basically, what's set up there is if you do need to collect medical information, you do need to follow certain procedures and certain practices in terms of how you do that. For Ben's previous company, because I don't necessarily have experience here.
Yeah.
In Ben's previous company, they had to deal quite a bit with HIPAA regulations to collect like speech information. And for that, it's all about anonymizing what the sources are, making sure that things aren't very readily trackable directly to any individuals. And you need to work with both the clinicians and the health service providers in order to try and get all of this all of this data properly anonymized and then sent to you. But it's just a matter of like corresponding to your local regulations for the most part.
This. Oh, sorry. Go ahead.
Oh yeah, you can go ahead, Ben. You probably.
I was just gonna. Well, no, I won't take too much time, but I will say that actually, I think it's before I started at Metabob. I actually did a little presentation on how to do HIPAA compliant data collection pipeline. I can later today or probably tomorrow. I'll make a reply to your GitHub comment with a link to my presentation that I did. And I didn't do it at Metabob, I did it at Oracle, but it's based on work that I did at Ellipsis. So, but now that's American law, HIPAA. There's 2 A's and 1 P. Okay, and again, you're in India, right?
No, Rasim is actually located in Baku, Azerbaijan.
Oh, well,
okay. So it's even.
Sorry, I have no idea. I have
yeah.
no idea about the law in Azerbaijan. I don't know. Saku might know. I don't know. But anyway, I would guess that they would want to follow HIPAA because, I mean, unless they have their own laws. Yeah. But I will say one thing. Just one thing to say specifically about how to collect the data. That's how about how to protect it, but how to collect the medical info for AI processing. Just like Avi said at the beginning, you really have to know what your goal is. For example, in our case, the goal was to detect depression in speech. Okay, so we're using PHQ scores because that is the legally recognized criterion for deciding whether somebody's depressed. There's a big problem with that in that it actually doesn't do a great job of predicting depression. We actually don't have a good test to detect depression. So you do have this problem that, are you trying to the PHQ score, or are we actually trying to detect depression? And you have to get that. That's a hard question because the answers are really trying to detect depression. Okay, let's get the data on really depressed people. Well, then how do you know if they're really depressed? Oh, there's not a good test for it. So you're in this cycle. So like Avi said, you collect data, you do your best, you tune your methods, you tune your goals as you go along. You have to do it. Yeah. So it's that was a hard one, but that company's getting better numbers now, by the way, I heard. But anyway, that can be a long side thing. But yeah, you have to know what your goals are, especially, well, depending on what you do in the medical field. If your goal is something well-defined, like is there a cancer in the lung here based on the image, yeah, you can get training data for that. There's actually a lot of data about that particular one from a CAT scan. But if you're doing it for a goal which is not well defined, that's one thing you're going to be always chasing your tail, trying to find out, we predicted something, but it wasn't a high accuracy. Why wasn't it a high accuracy? Because what we're measuring is not very well defined. And you do go in that circle.
Yeah,
it's hard.
and
Sorry.
to get out of the circle, sometimes you need to go and get more data, but that usually requires
Yeah.
working with the actual health staff in a way that
Yeah, exactly. You have to work really close. That's main lesson learned at that company, and why that company I think had some success later. It took them a while, but yeah, we actually had medical professionals working with us who were very familiar with how to evaluate depression, how to interview a patient, what kind of situation, how to develop rapport with the patient. You really need a lot of human, experience with that. Yeah.
And
Anyway.
to add on that, because Ben mentioned the name of Ellipsis Health, that was actually a company that piloted at my college campus. So we were able to use their telehealth service for free. And it was actually on a pretty good stage already, I thought. As a product.
We were desperate. I'm curious, that was after July 2018, right?
Yeah, that was last fall at Menlo.
Yeah.
But you can't take credit for it being good.
That's right. I think I know who made it better. I think I know exactly the person. He's in Toronto now. But anyway, yeah, I know. I know. Yeah, he followed on my work and he improved it a lot. So, yeah.
Nice. Well,
and we also had a lot more data, a lot more training data in the model too. And now, is it because his model was better, or is it because we had more training data? Yeah, I don't know.
We understand, Ben. We get it.
Yes. Yeah. Okay.
All right. Thank you, Ben, and thank you, Avi, for that answer. I'm sure Rasim found it very useful. He's currently unable to speak. He messaged me on Slack, so don't be surprised of that. He probably just sent something in the chat. I would think so.
Okay.
Yeah. He said he can't speak, but thank you for the answers.
Okay.
And Shandan, Shandan, I will provide the PowerPoint later next week. Just check the chat, and I will mesh it with our own presentation. But let's move on the GitHub question. So the next question is that how discrete mathematics, analytics, NLP, statistics, deep learning, ML, etc. Stuff are directly linked with AI or required to learn AI?
Well, of that list of things, most of them are AI generally, or rather are forms of AI. So machine learning, NLP, deep learning, and even like analytics and statistics to a certain extent are all like different forms of creating artificial intelligence, quote unquote. there's just different techniques to create meaningful patterns from otherwise meaningless data that you're just collecting in. And since that's the goal, basically all of these are just different tools in your AI toolkit to achieve that goal. So they aren't like required to learn AI, quote unquote. You could focus on like any one of these, but like if in order to understand the space, you need to have like a good foundational understanding about statistics and how to do like data analysis and just like proper scientific procedures in order to like learn whether or not what you're doing is actually generating real patterns, or are you just seeing like ghosts in the data and just assuming that they're true because you want them to be true, as well as going through and like doing the more sophisticated techniques like NLP, deep learning, and in more general ways like ML and discrete mathematics. So that's basically the whole space. So they are directly linked with the idea or notion of AI. And if you want to create an AI, you'll need to know at least some of them, if not all of them.
Cool. I'm sure that answered the question really well. And a question from the same person is that, is R programming required for AI? Which is a great question because that is actually the only programming language I have ever used. So I'm curious to know the answer as well.
R is like specifically designed to be good at doing data analysis. So it's not required for AI, but it is required for, I mean, it's not even required for data science. It's the right tool for certain kinds of jobs. And if those jobs are data processing or like data analysis on like raw data, or even doing like certain steps of the data processing pipeline and then doing the analysis on that, it's a very useful tool for that. So if it's something you're familiar with, then you should use it. If you aren't familiar with it, then you don't have to use it. There's other ways to do the data processing. Like if you're willing to shell out money, you can use MATLAB. And if you're not willing to shell out money, you can also use Python. And either of those are also like perfectly serviceable solutions to like do the same goal. But R is more specifically focused in that area, so it may be easier to pick up if what you want to do is like data analysis or data science.
Perfect. And the next question is from Rasim as well. So how software engineers can easily move to AI field? Do you have some fast track roadmap suggestion for it?
I don't have a fast track roadmap, but if you are currently a software engineer and you like have experience creating software, then you understand on some high level the basics of how all the actual like AI frameworks and libraries, how their APIs are going to function. And if you have that level of like knowledge or experience with just how to interface with an external library and how to pipe in data in a way that is conforming to what that library would expect, then you've already done half the battle for most people who are new to the field and programming in general, which is learning how to like feed in the data and how to format it and regularize it so that it works properly. So I would say that there isn't really like a fast track to it. You should get some sample data sets and like try out the methods. But I don't have anything off the cuff that I can just tell you. Just follow these methods and you'll get it. But if you have software engineering experience, you have all the groundwork to at least get things working together. Then the next step would be to get the data and get the AI framework, and then just start feeding things in and seeing what the outputs look like.
Awesome. I'm sure that answer was really helpful for Rasim. And let's move to Fiza's question, which is actually two questions. So what are some resources for good AI projects we can work on? And apart from Kaggle, sites we can check for getting data.
Yeah, so Kaggle provides really good like pre-parsed and pre-processed data. If you're willing to work with more raw data, there's this GitHub repository that is fairly frequently updated. I put it in the Zoom chat, but I could probably share my screen quickly, or Alex can click on it to share his screen. It's just a list of different sorts of like data sets that are available and links on how to get them. So for they're usually set up in like different sorts of formats. So you're going to need to do some things specifically. The other place to get these data sets are more directly from universities themselves. So if you do like a Google search for them, you can like add for university data sets, you can usually find the stuff that people are collecting to do their actual research. And for a lot of them nowadays, they actually also upload their raw data as well. So you can also perform your own analysis on it and like aggregate from multiple different universities and like do the actual processing. And that sort of open sourcing of all of this data is also what's enabling people to be like get more involved in the AI space. I should probably reply to this. I'll add a comment to this with a link to one of the things. Hold on.
Perfect. Thank you for that answer. And then the next question is 4 questions. So I guess let's do them one by one. So the first one is that what is complete workflow of data processing?
Yeah, so basically, as I mentioned before, the complete workflow is basically you would get some information into your data pipeline. Let's say you're using like PySpark or something, and then in each one of these steps, you would take the raw data, you would format it or regularize it so it all has the same components, and if anything is missing or not there in certain inputs, but is there in other inputs, that you would be able to control for that, and then you would feed them into a central table, and then you would then do whatever subsequent steps of processing you would need to do in order to reduce the feature set from the raw data into each individual step. So it kind of depends on what you're doing and how many steps there are. There could just be one step where you just get the raw data, put it into a table, and then you're done. That's your data processing. You have very good data you're probably collecting from like a device that you've also created in that case. So everything is using the same format and the same message passing system. If you're getting data from external sources, it's very unlikely that everything will look nice when you get it in. So you're going to need to do the regularization step, get everything looking correct and like in a format where it's easy for your team to analyze. Then after they do some analysis, they may realize they need certain features aggregated, or they realize that there's certain things that are important that are across multiple different items. So then you would need to form that in your data processing step, and you just keep doing that until you run out of things to process or have already processed everything you need to achieve your business goal, at which point you're done, and then you just feed them into the consumer. So either the person who's going to be using it as an end user, or even like your AI model to train it. So that's basically what the flow looks like.
And the second question from that same one was that is there resources to learn AI ops or ML ops that you would recommend?
So when it comes to resources on how to learn it, for the most part, like I am one of those people who keep saying like experience is the best teacher. So I don't really have off the cuff like tutorials or Coursera links to certain things where, oh yeah, I did this Coursera link and I learned how to do AI ops. It was more of a, I needed to do AI ops and then realized that there were some steps that needed to be achieved in a certain order. And then I stumbled my way to getting it functional and to a very useful level. And along the way, like you need to just do the Google searches to figure out, oh yeah, so if I'm trying to get data in from these sources, what's like the best way to do that? And learn essentially from aggregating all of these like Stack Overflow posts to be like, oh yeah, I should probably like see if Apache Spark would be useful for this. They may try and like give you a lot of tooling that they want you to set up beforehand and say, oh, just use this method and everything will be good. I would be a bit more skeptical of those sorts of things. Just try and focus on what the underlying process that they want you to achieve is, and not necessarily on what the specific tooling is that you need to use. Because like at the beginning, I wanted to set up like Apache Spark or something for feeding in our data, but also it wasn't really relevant for our use case because like all of it's just on open source repositories for the most part. And the stuff that's not on open source repositories is from inside of our own system. So it's already regularized and we don't need to have a lot of data processing in the way. So because of that, like all of those steps were just basically unnecessary. So as I like sort of highlighted during our presentation, don't do things that don't have immediate benefits, and then scale the operation to like better match what the needs are, as opposed to trying to fit all of your needs into like one overall framework just because it's like popular. However, that being said, Apache Spark is pretty straightforward to get set up. So probably start with that if you're going to be setting anything up.
Perfect. And then moving on from there, what is a glue catalog?
Glue catalog. Is this glue catalog? You're going to need to give me a bit more information there. Do you mean the AWS service or something else? Like, I assume you mean the AWS service. Basically, it's just a way of aggregating things from multiple different tables at the same time. So don't like, I haven't used it explicitly, but basically it's just a way to store things from multiple different sources and keep them in what is now being nicely called like data. Like it's more just all your data sources. So you can have like multiple different things like the Athena output, and then also like an RDS or multiple RDSs with different data in it, and this just sort of lets you find things more easily.
Great. And then last one from this is that, is there any AI-based database dedicated to videos and images?
I mean, I also don't know what you mean here. Do you mean like source data for videos and images? Because there's the internet that's full of videos and images, just right for you to take. If you want like to find specific images, there's a lot of like Kaggle data sets for like training GANs or other sorts of like methods that usually have like labeled images of like actors or like cars or dogs or like buses in there that you can probably take a look at. But for the most part, like videos and images are some of the easiest data to get unlabeled, but also very hard to label. You do need to like go through them and make sure that they are properly set up. So there's always some like legwork you need to put in for all these AI projects, which we didn't mention necessarily, but you need to have somebody to go through and like check all the boxes for each one of the things.
Yep. And
you mean a database that provides more features? Not that I'm directly aware of. When I was doing video or image analysis, I was using a much different technique, and I already had the source data for that for the most part. So I don't have any good answer for that question this time.
all right, that's totally fine. And let's move on to our last question, which is about Metabob. And I think even I could answer this question, but Avi, I'll leave it to you. So do you have any plan to, because like Metabob is very useful since I used, it supports only Python, which is true. But do you have any plan to get add support for other programming languages in the future?
Yes. Yeah. We are currently working on, I guess in secret, but now it's being recorded. So we are going to be considering releasing support for other languages in the future. We're trialing out our model on a couple of different languages right now, and depending on how quickly we can get it up to the same level of performance as our Python model, we'll be releasing it in some time in the future.
Alrighty, and I said it was the last question, but it really wasn't, because there's more. There was just a couple answers in between. So let's see here. What is the process to be followed while implementing AI typically in a company environment?
Well, like with everything, it depends on company to company. Usually what happens is if there is, it also depends on the use case. If you're using AI to develop a product, that's a different sort of workflow than to use AI to improve your business processes. For business processes, the first step would be to get somebody in charge. The second step would be to get that person to outline enumerate all the data sources and all the data that they want to be collecting. And then it would be to build up the data pipeline and then hire some data scientists to start going through and building out features and maybe like an actual AI researcher to help you create some predictive analytics potentially. For the most part, you don't need like the hardcore researcher type for things that are more internal to a company, simply because the types of things that you would want to be detecting are more anomalous changes in your company's performance, or like other sorts of features like that, which are easy enough to do with statistical methods for the most part. You don't need something more sophisticated usually. If you were doing it as a product development pipeline, the steps are the same, but you kind of need to, but the problem itself needs to be more well defined. And you probably also want to have somebody who's in charge, who's also willing to do the additional research to determine what the best approach to use would be.
Cool. And I guess the next one really depends on the situation, but how long does this process usually take?
Multiple months to a year. Depends on what it is, obviously. For the business intelligence stuff or like just getting your processes, if you're a very small company, it could take like maybe 4 months to get the AI pipeline in place, or to get the data pipeline in place. And then also well used by all the team members, and then maybe another like 2 months to get all of the analysis up and running and start to produce like something that's potentially usable. For product development, depends on the product. For something like our product, we're still kind of developing it right now. So it could take like a year, multiple years. Like for our specific issue, like we'd probably be working on it indefinitely, simply because the domain that we're operating in changes all the time, because people use different architectures, the programming languages are evolving, the libraries are evolving, everything's changing. So you need to stay on top of it. So you need to have everything set up so that they can learn adaptively. I can probably just answer the next question. How do you think, what is the impact of AI in the near future, and would it be able to replace some jobs? That's kind of the goal. You would assume that it would be able to replace at least the main jobs that it's currently relying on humans to do, which is labeling to some extent. There's a lot of research that's going around, like doing certain types of detections and like better discriminating between different types of items. And then as you sort of extend on from there, you start automating away the stuff that is more rote first, simply because they're more regularized operations. So things that don't require like new solutions all the time, that operate on a very fixed domain, are going to be the first sort of things that are easily automatable, especially if they are purely digital. So anything that is in that space would be the first things to go out of the way. And that would be the main impact. It would basically just be a transition of the human workforce to more sophisticated problems until there comes to be other issues that arise. But that's more of a social thing and depends on a lot of other factors as well.
Great. And then Nurlana's last question was that what recommendations can you give to the CEO or the individual who has not used AI yet?
Like, think about what your business is, and AI might not be the most useful thing you could do to improve your company at the moment. So I know it's cool and it's got like a nice buzzword and like really helps out, but sometimes like as I have frequently mentioned in this question and answer section, and also during the presentation, like you need to scale up to your problem. So you need to understand that the most efficient solution will usually be the one with the least amount of like moving parts. And to get an AI up and running, that's a lot of moving parts. So in order to like build up to that, you need to understand that you want to basically understand what your problem is. If you are CEO of a company, you should already do that just in general. And then you need to consider, will AI provide a competitive advantage that isn't easily achievable by any other method? And you may not have the answer to that, but if you want to start pursuing that sort of path, you should work your way up there slowly. So like start with the more basic analytics. If that's helpful or along the way to be helpful, and it just needs a little bit more context or a little bit more information, then maybe AI could be the way to get that additional context. But if it's not, then it's not, and that's just all right. That doesn't have to be shoehorned into everything. It's not a mature technology yet necessarily, and certain problems are not well fitted for the current techniques domains, simply because they are complex or they have a lot of external factors that aren't easily like placeable within the feature vector that you're feeding in, and that they don't fit the curves nicely because they aren't complex enough in the right ways.
Perfect. And to close out the questions, Akhil's last question is, what are the best books to get started with AI? And while you answer this, I will open my presentation again for the wrap up.
So like with everything else, I don't have like a list of books on offhand when it comes to getting started with AI. I sort of picked it up by doing it for the most part. I was involved in like quite a few projects with some more senior AI people, and that's kind of how I learned about it. And also the methodology and everything, that whole thing was something that was mainly learned through my independent research along with my like mentors, assistants. So I didn't do any like formal study in AI specifically, and I don't think that's really necessary for most things in the computer science field in this current day and age, simply because of how available the information is and how available computers are. So it's very easy to sort of like learn the processes by implementing them and then seeing how they respond to your like hypothesis testing. So as you like work on things to try and say, well, what if I change these parameters? How does that affect the model? And then after you make those changes, try and understand like what the underlying reason was, and like go into the math and like see, oh yeah, well, if I change the learning rate here, what it's doing is it's amplifying how much each error is being cascaded throughout the entire neural network. And that's what's causing it to overfit to certain conditions much faster than others. And depending on how I tune this and how many layers I have and how many parameters there are in the model in total, and how the different layers are connected to each other and which transfer functions they're using, like all of this stuff has some interplay. So like if you don't immediately recognize what something is, like take a second, look into what that is, read the documentation for that library or that application about what that method is, go back to reading about like fundamentally what the math is and how it's being applied in this use case, and then go back to working on your thing, and then change it and see how it is actually affecting your model's ability to reach certain end goals. And that would be the methodology that I would recommend to do it. I know that's not for everybody. So, you know, if you do want to read a book, I don't have any book recommendations for you right now, but good luck.
Perfect. And that wraps us up the Q&A session with Avi. And Avi, thank you so much for all the answers. I'm sure that everyone found them very useful and helpful when starting in the AI space. And to wrap up this session quickly, I have included Avi's couple contact informations here. So you can find Avi obviously from LinkedIn, but you can also find him from GoUp Slack. and that is probably the most efficient way to communicate with him if you want to follow up with something. And that being said, this concludes our webinar for today. So remember that we are constantly looking for community managers, tech writers, in and out ambassadors, marketing creators and editors, and course creators and project creators. There are links included for both Gopal's website and also Metabob's website if you guys want to go check out the tool. And thank you everyone for joining us today. And thank you so much, Avi, for taking the time to come speak to our community. I enjoyed the session very much, and I'm sure others enjoyed it too. This will be uploaded to YouTube as well if you have to go back to some information that Avi just shared in this presentation. And I will also include the slides to the description of the YouTube video when I get them. So thank you so much, Avi, and thank you so much everyone joining us today. And remember that we will be back next week with another webinar. So this concludes our session, and everyone have a good Sunday day or Sunday night, depends where you are located right now. I will jump into a lake for this whole day because it's basically the only way to stay cool here. So I hope you are enjoying our Sunday, and thank you guys for joining, and thanks, Avi. I'll see you next week. Bye.
Yeah. See you guys.